Welcome back, goobers. We saw some cool physics in the vodka filtering we did last week. Like these standing waves in the column of vodka pouring out of the filter. The surface of the column needs to minimize the energy it takes to maintain itself, so it's trying to make a sphere. But the flow is moving too fast to complete the sphere before it moves on, so we get nodes instead. It looks like a standing wave, which is what happens when you have the flexible object fixed at both ends, like a guitar string or a skipping rope. But from a really short literature search, I didn't find an explanation for this beyond the Rayleigh Plateau instability. Here's a more extreme example of the Rayleigh Plateau instability, and the stream is forced into droplets. Last week, our viewer Dennis pointed out that filtering vodka and water generates heat. This heat comes from the fact that there are polar molecules in the vodka, and they start to align so that the positive end of one molecule sticks to the negative end of another, and this configuration takes less energy, so the extra energy that's left gets moved around as heat. So everything starts to warm up and we get a little bit more vapor in the system than we would normally have. And so this vapor forms a layer between the droplets and the rest of the reservoir, and you get this Leidenfrost effect of the droplets floating across the surface. And I spent probably 20 minutes just watching this for fun. We also have these trapped air bubbles from the vortex at the bottom of the column of vodka. So that was a neat little pile of physics that we found in our vodka filtering goofing off last week. And if you want to see more science gooey stuff, then don't forget to follow us on Facebook, Instagram, and Twitter.